Hey everyone, welcome back. Today is the day 1 of the Vector Databases 0 to Hero series. In this video, we will be exploring what is a vector database, how does a vector database even work, and why do we even need vector databases? What is the need for vector databases? And also we'll explore some vector DB use cases. So let's get started. Okay, now let's start with the definition of a vector database. A vector database is a database designed to store, index, and search high-dimensional vector embeddings generated by embedding models enabling semantic search. Now, at first glance, this definition might actually feel a bit confusing, and that's completely normal as it hides several fundamental concepts that power vector databases. And I'm sure your curious mind already has few questions like, what are these high-dimensional vector embeddings, right? And how are these vector embeddings generated by the embedding models? And what do we really mean by semantic search, right? So these are few questions that might come up at this stage. And once we get past all these concepts, right, even deeper questions start to come up. Like, for example, how do vector databases index these high-dimensional vector embeddings? Or how are we able to search through these high-dimensional vector embeddings so efficiently, right? So these are the key concepts that we will break down and understand step by step as we move through the course. So at this stage, if this definition is a bit confusing, that's completely normal. Be rest assured that towards the end of this course, all these concepts would be crystal clear. Now, in this lecture, let's go one level deeper and understand how a vector database actually works step by step. By the end of this lecture, you will clearly understand the entire vector database pipeline. At a high level, almost every vector database follows the same core pipeline, regardless of the vendor. So let's break it down. First, we take our raw data. This could be text, images, documents, code, or anything else, and then pass it into an embedding model. Now, what is an embedding model? An embedding model is a machine learning model that converts data into numbers in a way that preserves its meaning. So here the embedding model's job is simple. It converts raw data into a long list of floating point numbers. Now, what are these floating point numbers? These numbers capture the meaning of the original data. Now, these are also called as vector embeddings. Now, don't worry about vector embeddings for now, as we have a dedicated lecture on that later. But for now, just know that it means that two pieces of content that has similar meaning will have vector embeddings that are close to each other in the vector space. Okay, now these vector embeddings are stored inside the vector database, but these vector embeddings are not stored alone. Along with these vector embeddings, you can store some reference to the original content, and also you can store some optional metadata. Now, I want you to pause here for a moment and imagine that you have stored 1 million images in this vector database. Now, to find the most similar images to a query image, you will have to search through all the 1 million images, and that would be a very slow operation with a complexity of big O of n, because it's just a linear search. So to make search faster, at this point, the vector databases under the hood performs vector indexing. And this is where the actual magic happens. So instead of scanning millions of vectors one by one, the database builds indexes using different approximate nearest neighbor search algorithms to make similarity search extremely fast. Now don't worry about vector indexing for now, as we have a dedicated lecture on vector indexing where we'll cover all the different approximate nearest search algorithms. Now different databases use different techniques here, but the goal here is always the same: fast and accurate search. So everything we have discussed so far happens in what we call the ingestion phase. Now let's look at what happens when a user actually searches. When a user or an application sends a query, for example, let's say user searches, how do I improve my focus? We pass that query through the same embedding model. Now I want you to pause here for a moment and think, why the same embedding model? It is because all the embeddings must live in the same vector space to be comparable. That is why we need to use here the same embedding model. Okay, so once the query embeddings are generated, the query embedding is then used to search the vector database. So here, the vector database internally searches the vectors that are most similar to this query vector or query embedding. And once the nearest neighbors are found, in the post-processing stage, the results are ranked by similarity score, and then metadata filters are applied if needed. And finally, the top k most relevant results are returned. And these concepts, whatever we just learned so far, is what powers your semantic search, recommendation systems, RAG pipelines, and modern GPTs. Okay, so to summarize here, overall, we can split the entire pipeline into two phases: the ingestion phase and the retrieval phase. Now, obviously, different vector databases optimize this pipeline in different ways, but the core idea remains exactly the same. So why do we need vector databases? Now, before understanding the need for vector databases, let's try to look at the types of data that we have today, right? So first we have structured data, right? Which are like tables, rows, fixed schema, right? So this is all structured, right? And then we have semi-structured data, right? Like JSON, logs, events. And then we have unstructured data. For example, your texts or PDFs, audio, video, images, right? These unstructured data, right? This data is actually high dimensional, right? It is unstructured, and this data is all meaning based, right? So the thing is that traditional databases cannot store this data, right? You can store it, but you cannot store this data at scale and perform search on this data, right? So that is where the traditional databases would struggle. So vector databases mainly target this unstructured data. We can store these unstructured data inside vector databases. Okay, now you might ask here, okay, what's the problem with traditional databases? Why we are not able to, search this unstructured data inside traditional databases? Because the problem is that traditional databases, they perform keyword-based search, right? Because these traditional databases are optimized for exact matches, right? You can do some exact keyword match within traditional databases, or you can do some range queries or joins and transactions, right? But the limitation for traditional databases is that whatever data you store here, it doesn't understand the meaning, right? So that is where if your keyword search would fail, then the traditional databases would struggle to retrieve this information that is stored inside traditional databases, right? So for example, if you try to store a PDF, the only thing that you can do here is perform some keyword based search, but if that keyword is not present inside the PDF, right, even though the user intent is same, it will not be able to retrieve that information, because here the only thing that you can do is you can do keyword based search. You cannot do semantic search, you cannot do meaning based search, right? That's the main limitation of traditional databases. And whereas inside a vector database, you can perform semantic search. So you can search these information, whatever information you have stored here, you can search based on meaning, right? That's the power of vector databases. Okay, now let's try to take this one step deeper and understand what makes vector databases so different from traditional databases, right? So vector databases are designed to store high dimensional vectors, even thousands of dimensions you can store inside vector databases, right? So you can store high dimensional vectors. We'll understand what are vectors later in this course. For now, just understand that we can store high dimensional vectors inside vector databases, right? And these vector databases, they uses vector indexes. They use the concept of clustering, and they use the concept of vector based search, right, to optimize this search and make it more efficient, right? So using these algorithms, it also make the search efficient, right? So the benefit we get is fast search. It can search millions of vectors in milliseconds, right? While also preserving the semantic meaning, right? So that is where the vector database is very efficient. So even if you have millions of documents, right, it can perform search efficiently because of these vector indexes. Now we will cover in depth, right, later on, all these vector indexing techniques that are there inside vector databases. But for now, understand like why this search is so efficient, because of these vector indexes, right? So here's the key point. So vector databases scale because they avoid the brute force search, right? They don't search in the linear fashion, right? They avoid this brute force search, and instead they use smart indexing and approximate nearest neighbor search techniques to find similar items in milliseconds. Now this is a very important concept, the approximate nearest search techniques, and we will cover all these techniques separately. But for now, this is what is actually powering your vector databases. And this is a very important thing to note at this point, right? This is what is the concept that powers vector databases. Okay, so now let's summarize the differences between the traditional relational databases that we have and the vector databases, right? So traditional databases, they work based on rows and columns, right? You can store your data in terms of some fixed schema in some rows and columns. You can perform keyword-based search, and the search is mostly done using where clauses, and it's schema driven, right? It's not that flexible, right? It's schema driven. So this is what we already know, the traditional databases. Whereas the vector databases, they can store vectors and embeddings. What are vectors and embeddings? We'll cover in the later lectures, right? What are vectors and what are embeddings, right? And so vector databases can store these vectors and embeddings. It can perform similarity search, again a new jargon which we will cover later. What is a similarity search? And it uses nearest neighbor search algorithms, again something we will cover later on. What are these nearest neighbor search algorithms and how they are used to perform similarity search. And the most important thing is that vector databases, right, because it can store all these vectors and embeddings, we're able to perform here meaning-based search, right? So it's all semantic search within a vector database, right? So these are the key differences between a traditional database and a vector database. Okay, now one important thing to note here is that the vector DB, right, your vector database does not replace the traditional databases, right? So in real world applications, right, this is the typical setup that you would find. The traditional databases are still used as the system of record, whereas the vector database are used to build a semantic retrieval layer on top of your traditional databases, right? So both are used together in any real world applications today. Okay, now let's explore some vector DB use cases. So vector databases are heavily used in building recommendation systems. It is used in building NLP-based search, where you can search using your natural language. The same technique is also used in building RAG pipelines to give more context to the LLMs. So vector databases power these RAG pipelines. Next, it is also used in building fraud detections and anomaly detection features. Now, these are just few use cases that I wanted to highlight here, but then there are many more similar use cases that you can build using vector databases. Now, in this lecture, we'll go through how it is used to build recommendation systems. So, vector databases are used to power these recommendation systems, which you might have seen in, some popular platforms like Netflix, Amazon, or YouTube. So all those recommendation systems that you see on these platforms are actually powered by vector databases. So how it works is that both the users and the items, they gets converted into vectors. So the user vector is nothing but the behavior of the users, like for example, what the users are clicking on, what they're watching, what is their watch history, or what is their purchase history. Those user behaviors are actually stored inside the user vector. And then you have these item vectors, like for example, the movie reviews, the product reviews, or like the actual product specifications. All those things, all those features are actually nothing but your item vectors. So both the users and the items, they are converted into vectors and they are stored inside a vector database. And then you can perform now on top of this data that you have inside the vector database, you can perform similarity search using the nearest neighbor search algorithms and then return the relevant recommendations to the users. So this is how you can build recommendation systems using these vector databases. Okay, so to wrap up this video, we covered a lot of ground in this video already. Like we understood what is a vector database, how does a vector database actually work, and we also understood the need for vector databases, and then finally we explored some vector DB use cases. So hope you found this video useful. In the next lecture, we will understand what are vectors, and we'll also understand this important concept of vector similarity. Thanks for watching.